Hello, in this video you'll see how an invoice can be generated, or rather a generator for invoices can be set up for Excel in C#. In this case it is specifically .NET 9, although in earlier versions you should be able to use the same library. We will be using ClosedXML, which is a free open source library, so there is no fee or anything like that. And of course you can try it out yourself. This will be a sort of step-by-step thing. We will establish some structure, some files in the whole arrangement, and we will have some kind of invoice generated by the end of all of it. So let's get started, and first of all let's create just some general files. We will of course need some data for the invoice. In this case we will skip business details, but it will include still basically invoice number and date, and also just the data for the invoice, all the items, and the items can be dynamic here, so however many items you provide, we'll have the totals for each item with the value added tags. We'll also add a bit of that complexity, and of course the totals for the whole invoice. So let's get started with adding some files to the whole arrangement. Now in this case you might think that the first file should be perhaps some kind of a method or something like that, but I would say it would be best to start with the actual structure for the invoice data. That is to create those data models, those few classes that will contain all the data for the invoice. And in this case, since we are kind of doing something relatively simple here, we will probably need some class for the invoice, where we can set all the data for the actual invoice, and also then another class for our invoice basically list of items object. So we'll have a list of some items, we'll have quantity and price for them, and it will add up to the total, but we can certainly create a separate class for it. So we can go to a project. Obviously if you have a web API or something like that, it would be a bit of a different arrangement where you would actually put those models, but the idea would still be generally the same. And when making these sort of applications, it would be best to have it done perhaps separately in separate class library, or at least somehow sort of at least separated, so it's not in some general flow right away, because you will need to run it quite a few times to get all the layouts right. There is no preview essentially, right? We will be designing everything sort of in C# code. So since there is no preview, you will need to run it to actually preview what you have done already, and it is important to have that clear and good access to it basically. So let's create the first one, which should be relatively simple, although we should probably just start with a little folder just so we can separate, even though it's a small project, but we can certainly separate the models at least from anything else that we will have. Although that anything else, we will just have a generator, so a class for the generator, nothing too fancy in this case. But let's do the invoice file. Let's do invoice file, and then we can also do a file for invoice item. So let's just make those files, get them ready, and then we can fill them in. So we have invoice, and then we can have, like that, we can have invoice item. And then another thing that we need to have, of course, is the actual class for the generator. We could, for the purpose of the example, put it in program.cs, but it will be easier to see what's going on if we separate it. So let's just create another little class, and let's call it ClosedXML generator or something like that. So let's say ClosedXML Excel generator, let's call it that, because we will be using ClosedXML library, and we are generating Excel, so it's ClosedXML Excel generator. I do believe that makes some decent sense in this case. Now let's get back to the models, and we can actually start with the invoice item. Now you might say, let's start with the parent, but the parent will require the invoice item to be complete, so we can actually kind of start from the child rather than the parent, which may seem counterintuitive, but it is in this case probably a bit better, because you have everything you need kind of to complete the invoice item, but you don't have everything you need for the invoice, because invoice item is one of those things that you need for the invoice. So just following that logic, we can start from here. So first thing what we have is probably the quantity of the items. Now we could have titles and things, so we will probably skip that just to make the example slightly more simple. Although you'll get general idea in the end where you would insert those additional fields if you need them. So let's start with a little public string, although it's not going to be a string actually. It is, let's zoom in a bit, it is going to be an integer. Let's do an integer in this case. It doesn't have to be an integer, obviously. The quantity is what we're doing. It does not have to be an integer. It can be the decimal, it can be double. Most likely, if you're doing something more dynamic, you would make it a double or something like that. But in this case, we can stick to an integer. It doesn't matter at all. So another thing, we can add some sort of random things, description and things of that nature. But let's skip that for now. Let's just do, say, for example, decimal. And that's going to be, let's say, unit price. So we need the price, we need the quantity. Those are the two basic things that we need, right, for this sort of data arrangement. Later we will actually get into Excel and we will see how we can arrange it in a structure, so then we can more easily know which fields to sort of occupy for which part of this whole arrangement in the actual C# code. So we will have a bit of a markup later on. But let's just decide on basics of values for now. So we have decimal unit price, and we also have the value added tax. We want to have the value added tax of VAT. So let's do VAT rate like that. Now, other than this, we have quantity. I believe that is a bit of a typo. Let's make it proper. So we have quantity like that, and we do need to calculate something. So we will need the total. Now the total will come essentially from the total amount, in this case, plus the tax. So we can't just get the total like right away. We need to first of all calculate the total price essentially for this whole item, invoice item, and then we also need to add the value added tax, and then we get the actual total for this item. That is kind of how it goes. So let's skip one line and let's do some calculations. We will do the calculations just like in line like this. We don't need to create separate methods or anything like that. Now, in some cases, you might have to. You might have to create a little private method or something of that nature. If you have a complex calculation, it might be easier. But in this case, it's just a basic multiplication, essentially. So we have decimal, which is going to be the amount, let's call it that, and then little lambda expression here, that's going to be quantity multiplied by unit price. And Visual Studio is smart these days. It actually was able to suggest the correct thing here, which is relatively surprising, but I would suggest never follow that advice. Actually make sure that it's suggesting what you actually need in the end. So let's do the AT amount next. That's going to be amount. Now this amount going to be multiplied by the actual value added tax rate. This is a decimal of a percentage. So let's say 0.2 would be 20%, like that. So this is the we already do decimal. We don't take percentage, we do decimal. And in general, you want to use decimals right away. You don't want to do conversions inside your application. That is not a very good idea. Now, you can store it in a database, but you should do the conversion somewhere else. It should be a separate thing. That way it's easier. Of course, if you do have a public library or something of that nature, you can expose it and expose it as percentage. So there's something to consider there as well. Now we can move on. We have the value added tax amount. We have the amount. So now we just need the total amount. And let's mark it in the name. We don't necessarily have to do that, but let's do total with the VAT, so not amount, but total with VAT, just like that. And that's going to be plus, not the VAT rate, but the VAT amount. So like that, we have our invoice item. Relatively straightforward arrangement here. We just have a quantity, price, and then we calculate all this total. So the total amount, as well as the total essentially with the value added tax. Now let's move on to the actual invoice. So the invoice class should be relatively straightforward as well. Let's just make sure to make that public. It will of course take the items, but it will also take the total. So just some basic properties that we need to do. We're not going to have the ID. Obviously, if you save it to a database, you would probably have invoice ID, not just invoice number. You might have invoice ID as invoice number. You might have invoice number and ID and all kinds of different arrangements. But in this case, for the purposes of this example, to make it just somewhat at least more straightforward, we will just use invoice number. And you see, we call it number, but we are making it a string. That is, I would say, a general practice when it comes to these things, unless you're actually completely sure that you'll always generate numbers. So generally, if you have some user input, allow them for a string. That makes everyone's life a lot easier. But that's just a side note. It always will depend on your use case. The next thing we can do is a little public datetime, which will be, of course, the invoice date. A very important part of the invoice. We will display it somewhere. We'll find a place for it. We will skip the customer name, I would say, or basically receiver and the sender and all those business details. We won't get into that, but as I mentioned previously, you'll kind of get the general idea on where you could put them and how you can move things around a bit to make them look good and put them in the right places. So the final thing, the most important thing, is the reason why we didn't create invoice before invoice item is because we need a little list, and that little list will be our invoice items. Now it's not going to be list of invoices in list in invoice. It's going to be invoice, let's say, item, like that. So invoice item, let's just make it items. And just in case, so we don't have problems with nulls, set it. So it's going to be an empty list, but let's set it. So we have invoice number, invoice date. That should be enough for now. And now we can use, we are using decimal. Generally, you use decimal in these arrangements, but we need the total amount. However, it's not going to be get set. We don't need to calculate it separately somewhere. We can do it all in this class. We are using modern C#, modern .NET 9, so we can certainly use this thing that we don't even need to write. The Visual Studio will suggest exactly what we need, it seems. So we have total amount, items, sum. That is all that we need. Now, you can watch one of the other videos, one of the recent videos on this channel, if you have some more complex things where you need to group by certain items perhaps and calculate the amount. So instead of using group by, we do have now count by, an aggregate by where you can do the sums a lot easier in those very complex arrangements. So do check out that video, very interesting. Link improvements in C# since .NET 9. The next thing will be the total with VAT. We need the both total separate on both the general invoice and on each of the items. I will leave this in now. I will change that later, just so it's quicker to kind of set up the names. And then it's gonna be total with VAT. This is exactly what we had in the previous one. So now let's see, total with VAT, like that. And then total VAT amount. Let's get back to the invoice. What was it? VAT amount it was. So we need the VAT amount. And now we have the invoice class. So now that we have the invoice class, we can open Excel, probably get a bit of a layout going, and then see how we can actually implement the whole thing. Now, just to make this a bit quicker, more efficient, we already have a little arrangement set up right here. This is kind of what we are shooting for in terms of the actual result for the invoice in Excel that we might get from C#. There are some general details here. Let's zoom in a bit. We have the invoice. Now we can have the word invoice or not. It is sort of your choice what you're gonna do with it. Generally you would have it, and generally you would have it next to the invoice number, which in this case does have a certain format. So we have short for invoice, right? We have the year, and we have a sort of serial number, if you will. Well, the whole thing would be a serial number, but every invoice for that year would be, first it's 1, then it's 2, then it's 202. So we have some kind of format, and we'll try to include that into the whole invoice process. But you will see this part will be kind of separated, because generally you would want to have, for something like this, the data set up separately, and the generator only generates the actual visual result. So the main thing here is we want to have the word invoice on the A1, and then we want to have a serial number, the number for invoice, in B and in C cells. So we will need to merge B and C cells programmatically in C#, and then we will need to include this piece of text. You'll see how that happens, kind of an interesting arrangement. But that is essentially the first part. The other parts we'll have some table, right, with some data. It will be a dynamic table, so it could be some space like this, it could be much larger, it could be just one single item here, and then of course we will have our totals. This is a bit different from what we'll have in the end probably, but the general idea is the same. We'll have those values, we will have the totals, and we'll have all those things. We may still get back to this, but let's start with this first part. So we need to generate this word, and we need to generate the serial number, and we need to take in something to something and put it essentially somewhere. So let's go to the file in Visual Studio, which is ClosedXML Excel generator. Let's make this class public, just like all the other ones are public. We're not playing around with interfaces or anything like that, just to make this a bit more straightforward. But in general, this is kind of a simple arrangement. I will also, in this case, set it as void. It could, of course, very easily be a task, which is what it should probably be in general. We can change that later. But let's keep it simple. Let's do just public void. And let's call it generate, say, Excel invoice, like that. So you have this, and we are now good to go with setting up our actual generation of the generator for the invoices. Now, For that, we will use a library called ClosedXML. So we need to get to the NuGet packages, to the NuGet manager, go to browser, and let's search for ClosedXML. Now, if you want to learn a bit more of a basic arrangement for this, watch a video on this channel about just generating some data with ClosedXML. It's a great library. It is open source. It is free to use. That is something quite important as well. It didn't used to be that way. It used to be more difficult with these Excel libraries and all the Microsoft Office libraries, but now we have these options, which is a great thing. So let's install this ClosedXML. It should be quite quick. Yes, it is quite quick. So now that we have installed it, we can get back to it, and then we can set it up here. We have lots of probably unnecessary using statements here. We can get rid of them, most of them. Let's see. Let's do using ClosedXML, and we will need the Excel. And we will also probably need let's see, invoice generator example. This is the project name, and we will need the models so we don't have those long namespaces in front of those classes, so we can just get to the models right away. Now, the generate invoice method will take some things. We can skip this part or not skip this part, but it will take some kind of an output path. Now, again, depending on where you do these things, it might come from environment variables, SAP settings, things of that nature. So you may not need this, or you may need this. In this case, since we have a console application, we will just put that in just so we can play around with it more easily later on. And also the source code, the full source code will be available on Patreon. Check that out. With a more premium subscription, you get free access to courses, some Blazor stuff, some C# stuff, SQL Server as well. You can learn all about SQL Server for a relatively low price in there as well. So let's first of all do invoice. The whole invoice, we take the whole invoice. We don't take items separately. There's no need for that, right? Because the items will be inside the invoice itself. So let's call it invoice. And then we just need a little, say, output path, so we know where to actually save it. Okay, to the interesting part. We need to establish a workbook. So for anything that you generate in Excel, you first need to establish that workbook, which is the actual Excel file that will be saved to your device, or to some other device it may be sent and saved. So let's do a using, just so we don't mess around with those resources. We make sure they are released. That is very, very important, because some things may not work right if we don't do that. So let's create a workbook. That's going to be workbook, like that, and then new, and that's going to be XL workbook. Excel, mind you, is XL, 2 letters, not the whole word. And we do not need the output path, although we could provide it there, but we'll provide it later, so it's more easily accessible and we can more easily view it. Okay, after that, we need a worksheet. So basically, a workbook contains a worksheet. And that's how Excel works. It can have one worksheet, it can have several of them. That's a basic sort of arrangement of Excel. And we already have a suggestion. So we have a workbook, then from workbook comes the worksheets, and in it we add some kind of a worksheet. We'll put a little name on it. Let's call it invoice, because we only have one. Now, we don't need to sort of construct it and add it. We just add it inside there, and we take a reference from it. So it should be a little variable like that. Let's say WS for worksheet, essentially we add it to the workbook. We have a reference for the workbook that was created, and we also have a reference for the worksheet that was created. Now, the first part, let's call it top invoice part, like that, so it's easier to kind of remember where things are. And now we can work with different cells. So we remember now we wanted to add the word invoice in A1. So let's do just that. We have cell, then we will have the name of the cell, the address as it would be called, and that's going to be A1. So whatever you see in Excel, you can access via the cell. You also later see we can access ranges, basically the same thing, but the range would access all the sort of available cells in that range provided. In this case, we access the cell, so just a single cell, and we can manipulate that in any way we want. We can change fonts and all those other things. So we can have a value. We're not going to change the font probably in this case. Maybe add a bit of a bigger size so we can see that it's invoice. So maybe add a bit of bold or something. But generally, let's leave it simple. So we have A1 value, and the value will be simply hard-coded word invoice. Of course, in some cases, you might want to have some kind of regional preferences and things of that nature. So language, basically. So you would pull that from resources. In this case, for this example, we just use a simple hard-coded piece of text, a little string. And then we need the invoice number, which is where it gets a bit more interesting. So we start the invoice number from B1, right? But if you remember, we saw that it's gonna go through 2 cells, but we still need to have 1 cell where we actually insert a word. It doesn't matter if we measure cells, we still need 1 cell where we insert the actual text or whatever it is we are inserting. Generally, you want to start with the first cell that you are merging. So if you're merging from B, then you put your text in B, and then you merge through however you want, from B to D or something like that, and 1 to whatever is the same thing. So let's do B1 value, and that's gonna be equals, let's see, invoice and invoice number. So B1 equals invoice number. Now, the interesting part, the merge, it is kind of straightforward. You just have to remember that you don't sort of maybe get the cells and add them up or do something like that. What you do is you get the range of cells. So just like you would select in the actual GUI in Excel itself, you get the range and then you press the button merge. In this case, we're not pressing the button merge. We are doing it via C#, but that is exactly what we are doing. So in this case, what we want is B1, and we want the cell next to it to the right. That's gonna be C1. So that's B1 to C1, the range that we got. Imagine we selected that in Excel, and now we can merge it. So let's merge like that. We use the merge. So this is, again, like clicking that button, it's merge, and we will merge it. Now let's just do a quick sort of thing, and we could actually take the cell here as a reference because we are working with it several times, but it doesn't really matter for the purposes of this example, and I do believe it will be easier for you to see the actual code. So let's add a bit of style. So let's add style, and let's go to font and make the font a bit bigger. Let's see, is it font size? Yes, it is font size, and let's say we want to make some like 16. Why not? 16 font size. Perfect. Now we need some kind of a way at this point, and as I mentioned in the beginning of the video, you do need that way to sort of very quickly be able to generate, whether you access maybe through unit tests on your local environment or something like that, if it's a more complex arrangement, or you have a separate library that you later add to the project. You do necessarily need that sort of access, so you can check what you've done and you can make those little changes. Maybe font size 16 is too small. Well, you're not gonna make a postman call to see that and get the download the file via another call and look at that. You need to do it quickly in your local environment, in your local basically arrangement. So just for us to actually be able to do that, we need to save the whole thing. And to save it, we simply use Workbook and save as. Let's see, save as, like that, and the output path. So this will be saved in the output path, and we can take a look at it. So once we run the application, simply run it, then we can open the file and take a look. In this case, in the program.cs, we already have a bit of an example set up. So we have the invoice number created, we have a date inserted, and we have a couple of items in this case. And then we just run the generator. Something to note here, in this case, if you run your console application in debug mode, it will output to your debug mode. So simply access the location of the solution. There will be a bin folder, and that's gonna have a debug folder, and in there you'll have all your application generated, and then you'll have this invoice xlsx file. Once the file is generated, we can see that it does indeed have word invoice, and it does indeed have those merge cells with our invoice number. Now, you could put a default cell size as well, so it can be read by default. Obviously, this is kind of what you want to do. Maybe we'll get back to that later, or maybe we'll skip it. But for now, we do have a decent arrangement here, so we can actually move on to creating a table and generating the values in it. In order to create a table, we must first establish a table structure. Now, this library certainly doesn't offer anything so specific in terms of table, like build table method or anything like that, or a class for a table. We don't necessarily have anything like that. However, we can customize it, everything completely. So that is very useful, but the first thing we need to do is build a table header, right? For the header for the table, basically. So for that, we will make a bit of space from all the invoice and things like that, both from the top and from the left, right? So from the letters and from the numbers of the Excel size, so to speak, we will make a bit of a space, but not too much. And then we will access different cells and put in separate values to them. We'll also add a bit of a style just so we can separate that, just so we can see how we can add a style. Let's make it blue, bluish on the header, and put a bit of a border. And I would say that should be decent enough on those parts. Now you can make it more dynamic, and you can do each cell different, and or rather each row different for each record, but that would make it quite a bit more complex. So let's mark this in a little comment like that. Let's call it table headers, or table header rather. And then we can start. We have the quantity, we have the amount, we have the value, so all those things need to be added. And the only thing that we need to do is simply, once again, access certain cells where we want to insert these and insert the values. That's it. So we have A3, then the value, and that's the first one gonna be the quantity. Quantity, I believe it's like that, right? So we have a quantity, that's it. And in this case, I would just say copy down a bit like that. I believe we need 6 or so. So then we need to go to the right. That's going to be not the next number, but the next letter, which is B. And then we're going to have C, and then we're going to have D, and then we're going to have E, and then we're going to have We don't actually need the next one, I believe. Or maybe we do. Well, we'll see later. Doesn't matter. Because we are only adding just essentially predefined values, so there's no inserting something from a class or calculating something or doing something dynamic. So then we have value, just like we saw in that little sample earlier on. And then we have the amount, and then we probably have the VAT. That's how it usually goes. And then we have the total. Now, this could be total with VAT as we did before, but we can just do total, actually. In this case, that is a more of a standard for invoices. So we basically at this point have our header, but let's make our lives a bit more difficult. Let's also add some style to the header. So we can have, let's say, let's get this range, call it RNG. Let's do it like that. We get range, and not like that, but from WS, the worksheet, we get range which gonna be from A3, so you can actually copy from here, like that, A3, let's do it like that, A3, and it goes up to E3. So now we have this range selected, we just take the reference for the range, because we will need probably 3 or 4 things here, just to add a bit more maturity to the whole thing, just so it looks more real. And I called it range. This is not a good naming arrangement. Let's do headers, header range, something like that. Header range, why not? And in the header range, we can say add some styles. Let's go with font, not the size. We could also do the size, but let's in this case do, say, bold, and bold set to true. Now, as you can see, bold is, we don't have like font weight necessarily right here, but we only have bold and italic, so we can't customize it too much, but we can customize basically almost to the point that you can do in Excel itself. So this is a very sort of dynamic library as well. Let's do header range, another one, and let's add a bit of a background color. Now the background color will come from style. Once again, anything that is style will be in style, but then you just have to go into alignments and backgrounds and fonts and things like that. Although I said background, so it is actually fill. So fill is what fills cell, or cells in this case, because we're dealing with range. You can do the same exact thing with cell, single cell, but you can do the same thing also with the range. So let's do background color. And the background colors, they do come from a certain arrangement, pre-arranged arrangement, so to speak. It comes from the Excel color. That's kind of important to remember. Excel color, we can have white, we can have all kinds of things. Let's do navy. Why not? A bit of a bluish sort of thing. And this is navy. So you kind of only can use those things. There is some perhaps limitation to this, but then even if you just look at these colors right here, there's certainly plenty of them to make it look relatively nice. Let's do header range, another one, just quickly. This part is quite important because we set the color black. You do always want to make sure you also change a font color that would represent the background color. This is a general sort of UX rule, if you will. But it is something important not to forget, and also always, if you are changing those default colors, do make sure it works on several screens, not just on your own probably quite expensive and quite good and quite bright screen, but also perhaps on that lower brightness and other such arrangements, so it actually works for everyone. This is something that may seem quite trivial, but it can go wrong, and it does go wrong quite often, and people complain, and that's not a very good thing. So we have the navy and we set the color to white, although on navy we could certainly set it to black, but we will see what it looks like. And at this point we do have a header, so once again we can run the application and see what the result looks like. So the result is quite simple here. We have our data for the headers, essentially, right? And we have our colors. Everything worked, everything works fine. And again, we are running it step by step. That is very important in these arrangements. And it doesn't really matter if it's Excel or if it's PDF. And you can watch some of the other videos on this channel, how to generate an invoice with PDF. There is an example, again, open source library, very interesting arrangement, a bit more complex than this. Quite a bit more complex than this, because you need to put things into the right places, so you need to run it even more often. But just to stress that point, you do need some kind of an access, direct access to the whole thing, to be able to run it as many times as you need. Now let's get back to the whole thing once again. At this point we kind of have the header set up, so we can actually set up the table itself. Let's do a few spaces here, and let's create a few things. First of all, let's create a loop, just so we know what we're dealing with. Not a for loop, for each loop is what we will need in this case. And the collection will be, of course, the items from the invoice. That was quite a long time ago in this video. Hopefully you remember we had items in the invoice, so we'll loop through those items, and well, we can leave the default word in actually, because it is an item, it is an invoice item, so we leave an item in. This then will be displayed in different cells below the header. So we start with free, index free, right? We can call it row index. But one thing to remember in Excel, in general in Excel, whether it's this library or the other library or whatever you're doing with Excel, they do not start with 0. They start with 1, like you see in Excel. So all the sort of indexes that we might be dealing with in terms of rows or columns, it will always start with 1. Unlike generally in programming, we're used to having everything start from 0. No, in this case, it starts from 1. So we just need some kind of a starting point here, I would say. And let's do, say, first data row. Let's do 4. So that's going to be 4, our first data row. And then we can create int row. You'll see y in a second, and that's going to be first data row. So basically, you can probably guess this is the current row in the current iteration. We could also use a for loop. Might be better, might be worse to some extent, but since we are starting from 1 like this, maybe it's easier to see in ForEach, and then we can deal with each item. But again, you can refactor the code in probably many different ways here. So again, we start from row 4, and that's going to be the first row, and then we will keep on adding each row. Before we do anything else, it even suggests us we can add the row plus plus. Now, I'm adding this because it is a sort of a good practice in general, because once you add a lot of stuff in that loop, several methods maybe, in this case it's not going to be that, but several different things going on, you may forget it, and then you may wonder why it's not doing anything, why it's only producing one row, why it's failing, why it's doing this and that. So better to just get rid of that right away and get going with something else. So after that, we just need the cell. So let's do cell. But in this case, it's going to be a bit different. We're not getting, like here, a specific cell. Well, we are getting a specific cell, but we are not using that address code. We are using indexes in this case. So what we will do, we'll go row, and I'll show the whole thing. We have the first one. So there are quite a few. Well, not quite a few, but some overrides here. So we can have the address, and we can have basically row and column. In this case, we are using row and column because it makes it a lot easier. You could, of course, do it with address as well. You could just do that stuff, changing numbers, but that wouldn't work for columns. So it's better to just use this approach. So the first parameter is row, and the second one is column. The column will always be fixed, right? We have a table, the records are in each row, so we just go down one row at a time, and then the columns are fixed. So we start the column from 1, and we will do it 1, 2, 3, 4, 5, basically, or 4. No, 5. It's gonna be, or maybe it's 4. In any case, we have cell row 1. That's gonna be value, right? Value equals, and then that's gonna be item quantity, probably, right? Quantity. Now, in this case, it's very easy to actually do all this thing because we can see it in the same sort of page, essentially, or what we need to insert. So we can kind of just copy down. We do have 3 and 5. So we have 5 cells in this case, and we copy down 5 cells as well. So we can then just do 2, 3, 4, 5. And then we can go above that, and we can see 3 is, or 2. I'm looking at this now. So 2, column 2 is value, which, let's see, do we have a value? No, we have, the value would be the amount in this case. So perhaps renaming is in order. Let's do not value, or we do have the amount. So, okay, so that's going to be value, and that's going to be that, probably. We'll double check that later on, doesn't matter at all for now. But we do have the amount here, so we'll probably need to double check that. We can do that by going into InvoiceItem right here, because we are getting the items. So we have quantity. The next thing is unit price. So let's copy this, and actually this is going to be the unit price. The next one is amount. That is probably how it goes. Yes. And then we deal with VAT, right? So unit price, then the amount, and then we have the VAT, which is VAT amount or VAT rate. VAT rate or VAT amount. VAT amount is what we have. We don't specify the rate, although we could specify the rate. That would be quite useful generally in invoices, but let's skip that. Why not? And then we have the total. Let's see, total of VAT. So we have VAT amount, we have unit price, and actually instead of value we could replace it. Now generally you could also leave it as value, but you might then also want to do something like amount. Instead of amount, you would do total without tax. Or you would do total with tax right here. So it's something to consider. And as you can see, even in this small arrangement, there can be a bit of confusion, which is perfectly normal. That's why, once again, we have that way of sort of testing it right away. We can run it. We can see what value is inserted, what value isn't inserted, and get all that going like that right away, without any sort of delay. So after this, we will probably need to take a look at what it looks like. We will need the last data row created in order to add some style to the actual border. But before we go to that, let's try and run it. And again, the quantity should be 2, unit price 10, VAT rate 0.2. And let's see what the result is. So in the result, the values are in, and they do seem to work. We have 2 quantity, unit price 10, and then the amount is 20, and the total with tax would be 24. So that's all good and great. Now, the only sort of last-ish step that we have. We need to perhaps improve a bit on that table, and also add the totals. So totals will be relatively easy. What is not perhaps all that easy is actually finding a place for them, and also finding the place for the whole design and style of the whole table, because we do have a dynamic table. We don't know how many rows it will be. It could be 1 row, it could be 100 rows, right? We don't have any sort of predefined limitation on it. So what we need to find, and that is going to be the most important number that will carry us through to the end of this thing, it's going to be the last row for the items, right? The last row, and that is the index, essentially, of the last row. And the way you find it, it's actually quite straightforward, right? Once we've thought of that idea that we need the last row, we can just, we already have the row right here. We have the row plus plus, we do it at the end. So the next row is already filled in. This is not going to be the last row, because once it finishes, it's not going to be the last row. So in this case, we need to do a little subtraction here. So we do have, let's say, last data row or something like that. And then let's do row minus 1, because we ignore basically the last one, as there is no item left anymore. We could do it a bit differently, but in this case, we keep it very, very simple. So after that, we need to add some data. Well, not exactly data, but styles to the cells, or rather, in this case, to the ranges. So let's do range, and we can get the range as we did before from the address, same as the cell. We can get it from the address, but we can also get it from these indexes. So let's do it like this. First of all, for the just a little sort of border arrangement, a custom border arrangement. Let's do 3, which will be this first cell, because we start from 3. We start the data from 4, but the actual table starts from 3. We want to include the border on all the rows, right? So not just the data part, but the header as well. Now, if you want to add different borders to only the data part in the table, the items part, then you would do when you would start from 4. So nothing changes really. we're just including the headers. So first cell column would be 1, and that's gonna be same thing for everything. And then last cell, we already have that. We have last data row, and then last cell column, that's gonna be 5, and the 5 comes from here, because that is our last column. So that's the 5, and last data row comes from this arrangement, basically the last row that we inserted, minus 1, because we kind of adding that this way in the loop. Again, you can do it differently, but basically that's the idea. We kind of just need to find that last row, basically find the sort of limits of the actual table, from the left to the right and from the top to the bottom. So relatively straightforward thing, but you do need to think of those dynamics, what you can define and what you cannot define. Obviously, we cannot define the item count, so we need to think where it begins and where it ends. Now, with this, we can do range here. Let's do a little border. So border, you go again to styles, and then you go to border for all the border styles. Let's do outside border equals, let's see, this one, and it's gonna be, you can choose again, just like you would in Excel, all the styles for the borders. Let's do a thin one. Let's keep it a bit more modern. Let's not do the bulky, nasty ones. Let's keep a thin border right here. And what I can actually do to some extent. Actually, in this case, to the whole extent, we probably need like 4 of these just to make it nicer. So we have this, and we also have the borders are interesting. There's an outside and inside border, so you want to do the whole thing basically exactly the same, both inside and outside border, if you don't want to separate those. So have a separation of insets and things of that nature, outside inset. But basically, yeah, so outside border, let's do the color, and inside border, let's do ins. Okay, right away we have the color. That's not what we need. Let's see if it... You want to put equals and then put a space so you get a suggestion usually. In this case, we don't get a suggestion because I believe it's kind of interfering with the lower part of this. And this is white. We certainly don't want white generally on the Excel unless we have a background. That's something quite important to remember because obviously the cells by default are white, so it's not gonna work white on white at all. Okay, we have this. We're not gonna run it. We're just gonna write it in the end. And the last thing that we kind of need is the total amount of rows, essentially. Well, to some extent, we need that. You'll see why in a second. We need to add those totals, but let's get that going, and you'll see. So let's do an integer and total rows. Now we could probably maybe make this better, or rather not total rows, but totals row we need is what we need. So here we get that boundary of a table, which is this piece of data, last data row. This is essentially the index where the not the border, but the table ends, right? And we want the totals below the table. We do want to skip a row or two, but we still need that data so that we know from where to skip that row or two. So let's take the last data row, copy and paste here, plus, let's say 2. Let's say 2. So now it will skip essentially 2 rows, and then on that one will one row it will create the totals row. Very, very straightforward. And for that we just insert those values in the cells. Let's see if we can get the actual cell. That's gonna be totals row. It's not exactly right, but we can tab this in. Let's see if we can, yeah, we can fully tab this in. Very simple. A lot easier to work with Visual Studio nowadays. It gives you all these suggestions, although sometimes all the wrong ones, which it is not exactly all the wrong ones in this case, but it does not need to be 0. It needs in fact to be let's say it could be 0, but we probably want to start from something further out, so we actually match those columns completely to the edge of the table. So the totals row essentially will be to the edge of the table, so we don't start from row 0, and we would not start from row 0 anyways because it doesn't exist. So let's move on. Let's create it like this. I think that's decent enough. So we have 2, 3, and 5. I think 4 and 5. Yes, that should be good enough. Obviously, the first one is not totals row. None of them are. But what the first one is gonna be totals. So we kind of have that sort of mention that these are the totals of the items, and then we can do the first one, invoice. Let's see, what would that be? Total amount, I believe. And then we have invoice VAT amount, total one. And then we also have the final one, probably. We have total with VAT. No, total with VAT. Let's see. It's gonna be total with VAT. Or it's gonna be the general total. Now, at this point, it's probably best to just check here. So we have the total amount, we have total VAT amount, and total with VAT. So this is what we want at the end. Let's see if we can make this happen. And then, yes, that's not what we want at all. We don't need that one. Invoice. Total with VAT. So that's our grand total, essentially, which we could have called that in the first place. But it is what it is now. So we have, after that, total amount with VAT. Total VAT amount rather, and the total amount. So that's the total amount calculated without tax, and then this one is with tax. And that's basically what we have. Now we could take a range and make this bold or something, or italic or something, to kind of separate it, or maybe create additional tables of table-ish definition, or we can wrap a whole thing in a table thing, but there's probably no need for that in this example. However, what there is a need for in this example is a bit of sort of formatting magic. You saw previously we don't have specified width and height for cells. You can do that. You can access cells and access those properties and set them one by one. But sometimes that may be a waste of time. Sometimes it may be a very useful or in fact necessary thing, because if you need to print something, you kind of want to have those very specific values. But in this case, we will do just something very simple. We'll go to the worksheet, and then we'll get all the columns, essentially. So we do, let's see, columns. Okay, so we get all the columns, and what you can do adjust to cell, or rather adjust to contents. So whatever the length essentially of a string is, of a number is in that particular cell, that column width will be adjusted to that. So that is what it does. And now let's take a look at the result. And the result is, as you can see right here, sort of exactly what we wanted. We have the totals, and you see that adjustment magic, so to speak, worked quite well. We have the totals, total amount, total VAT, and total. And as you can see, they do match quite well with the actual table right here. And we also do have those borders, so the design part worked quite well. And again, if you want to learn about this stuff on PDF, there are a few videos on this channel. You can take a look at them. PDF, generating invoice. They are on some older libraries, or rather not older libraries, but older versions of .NET, but they are still the same in .NET 9, exactly the same. So do take a look at them. Quite an interesting thing to watch. And since you watched this video already, it will be, I think, very interesting to actually compare, because it is a bit of a different arrangement. As for the source code, you can find it on Patreon. You can also find courses and lots of other different learning material in there as well. Very good courses on SQL Server for a very low subscription fee. And with that said, we will conclude this video.